Welcome to this talk on serverless beyond FaaS. I'm Vaclav Turecek. I'm a program manager here at Microsoft Azure.
And I'm Hongchao Deng. I'm a staff engineer in Alibaba.
And so today in this session, we'll present our view on serverless and specifically how we design the open application model for serverless applications. And we'll conclude the talk with a demo of open application model on Kubernetes. So as it turns out, serverless is a big trend in cloud computing today. According to analysts, serverless computing was the top trend for infrastructure and operations in 2019, last year. And it turns out serverless computing has been predicted to start actually reducing traditional IaaS consumption in the coming years. So the question is, what will this serverless revolution look like? So the definition of serverless can be somewhat nebulous. It's often defined as taking two forms, functions as a service and backend as a service, where functions as a service is an event-driven compute model, and then backend as a service is a set of third-party API-based services. But the definition of serverless compute as event-driven functions was generally popularized by cloud offerings like AWS Lambda and Azure Functions, and then subsequently reinforced by analysts and serverless working groups that often define serverless applications as compute that's bundled as one or more functions. And so the question is, does that mean functions is going to take over cloud computing? And so our answer is not necessarily. If you take a look at major cloud providers today, you'll find a serverless solutions page that talks about serverless applications, not just functions, but as a suite of products and services that allow you to build and run entire applications without thinking about servers or infrastructure. And so these aren't necessarily new products. S3, blob storage, Cosmos DB, these things have been around for years, but they're slowly coming together in a kind of a broader picture of what it means to run applications in the cloud. And this also includes compute services, so for web apps or containers, other things like that. So all of these serverless offerings kind of have a few things in common, which we refer to as the pillars of serverless, which are shown here on the slide. So storage and messaging services originally were built on a lot of these kinds of ideas. You take a look at queues, for example. You can request a queue in the cloud and there's no provisioning of infrastructure. There's no platform to manage. It scales elastically on your behalf, and you only pay for the messages that flow in and out. So functions and even PaaS solutions then went and popularized this idea for compute as well. So last year, O'Reilly did a survey on serverless technologies and found that the top reported benefit was a reduction in operational cost. So you think of cases where applications sit on mostly idle VMs and you're paying for the cost of the entire VM. So you can see how a pay-as-you-go model can save you money there. But the same survey also found that the biggest challenge was educating current staff. So we see this as especially true for functions as a service, because traditional application patterns don't always fit neatly into stateless functions. So consider an application where the internal state outlives the lifetime of any single request, for example. And so this is not to say that functions aren't useful, but they're usually part of a larger application. So for example, on AWS, according to Datadog, Lambda users are very likely to also use ECS or SQS or Kinesis or DynamoDB to round out an application. And similarly on Azure, we see functions users often make use of app service to run web apps, and event grid, event hubs for messaging, Cosmos DB for data storage, and so on. And so the challenge we see is in describing and operating applications that are composed of various serverless offerings, and that includes functions, as a cohesive application, and then applying across the whole thing. Or deployment and upgrade strategies. And so that's where the open application model comes in. So OHM is an open standard that describes a common structure for applications running on any platform. It also defines a separation of roles for application developers, app operators, and infrastructure operators. And this was a collaborative effort between multiple companies from the beginning. So one of the design goals of OHM is to allow infrastructure operators to provide a serverless application environment to application developers for any type of application or any form factor. So that's any kind of architecture, whether it's microservice architecture or on edge or on-prem or wherever. So as an example, in a private data center, you can imagine an organization's IT team can provide a platform on their infrastructure that surfaces a set of capabilities to developers that meet that organization's IT requirements. So things like compliance and security and that sort of thing. And in a public cloud, the cloud vendor would play the role of the infrastructure team by providing a serverless application layer up to the application developers. But the application developers have a consistent application modeling layer without any concern for infrastructure. So the application model itself makes no assumptions about hardware or infrastructure orchestrators, and that allows the platforms that implement it to provide a fully serverless experience for app developers. And so when we say serverless here, OHM focuses heavily on that first pillar that we mentioned earlier, which says that an application developer shouldn't be concerned with infrastructure. The other two pillars that we talked about for automatic scaling and consumption-based pricing, those are obviously platform choices that the model supports. We fully support those, but it doesn't strictly enforce them either. So you can imagine something like a consumption-based billing plan might not make sense for your organization's private data center. But we do want to focus on being able to provide a serverless application platform up to developers that's kind of a curated experience of the infrastructure underneath. And so here's roughly how it works. So the standard in its current form describes three primary constructs for application modeling. So we have components, which are things that you can run, like containers or functions or data stores or message queues or whatever. There's a concept called traits, which are behavior overlays for individual components. So this would be something like attaching a set of auto-scaling rules or ingress routing rules to an individual component. And then we have a thing called scopes, which are a way to group components together into applications. So this provides a semantically significant application boundary that you can apply to create applications out of a bunch of components. So these are the main constructs used in the model to describe the topology and behavior of an application, but they're also the main extension points. So platforms that implement the standard can decide what types of components and traits and scopes that they want to provide. So for example, a cloud provider can surface an SDN up through the model as a scope to allow a grouping of components around a network boundary. And so these extension points serve as a way to get around this lowest common denominator problem that you typically see with standards like this, where not every platform obviously is going to be able to implement all the same set of capabilities. So the model allows each platform to surface its own features and capabilities, but in a way that's consistent regardless of where it runs. And so this allows implementations to is going to show us an example of this running on Kubernetes.
Yeah, great. So what we just talked about is talk about OHM, and OHM is an open standard that lets you build extensible and powerful application platform. In Alibaba, we have many teams that adopt OHM to build to build application feature functionalities and provide management features based on OWN. And but like over time, we see that there are many like duplicate implementations and functions being like there, and we want to save our development time and also like unify the implementation. To do that, we build a project called Own Kubernetes Runtime, which is a community-driven project that provides the common OEM capabilities and functionalities and run as a Kubernetes plugin. There are many powerful application management features built in, for example, dependency management and the conflict detection. With Own Kubernetes Runtime, like platform engineers, they can build the platforms more efficiently and save their time. And for users, the APIs just become simpler and many hard work already handled in the runtime itself. In the following, I'm going to show a demo how we here's the overview of the demo. We are going to deploy a service check application which is defined in the own format, and it's going to be run on top of own runtime and the Crossplane, which is an infrastructure management platform as well. So let's go see the demo. So initially, I will log into my Linux box. Here, I'm going to build and deploy the own runtime. It's a controller on Kubernetes. So here I'm also like building the infrastructure like cloud provider for it as well. Now I think everything has been deployed. Now I'm going to check the CRDs, which is it includes the own CRD, which is capability provided by the own. We see that there are components, workloads, application configurations, and also the tree definitions, etc. And we also check cross-plane CRDs, which includes some infrastructure capabilities. For example, we see there's a Postgres SQL instance definitions here. And now we are going to deploy the service checker application as defined as an application configuration. Here we see that the components that the user defines service. For example, there are service checker UI, the UI, the data API, and there are flights API, etc. And we see that for each component, there are operational traits attached to it as well. Now let's describe the application workload. And we see that how it's defined using own. We see its workload has been defined, and there are also like additional parameters for user inputs. So finally, like all of this are very stateless, and they can run on Kubernetes directly. But like there are some additional services which we run on the cloud, which is the Postgres SQL. We use the Alibaba cloud like RDS to run as a Postgres SQL instance. Now, it's also been deployed. We check, that it's defined as a CRD, and we describe it. We will see that. So in describe, we see it's still waiting to bind. Means it's still not like officially like bound to the application itself. Let's check its status. So we need to wait some time. We check in the UI, in the Alibaba Cloud Console. We saw that it's still creating. But after some time, we will see it will be switched to running status. Let's just wait here. Mm-hmm. So after it's running, it will be bound by the cross-plane to the application directly. Yeah, it's all, we see that it's bound, and this like binding is automatically done. And finally, like as long as we have all the components being ready, we will use port forward to connect to the applications directly. Now here we're gonna refresh the data, which is gonna pull the data from just from the data source, and it's gonna pull into the database we just create. Now all the data is ready. It's been displayed on the UI as well. And the same also happens for weather. We're gonna put the data. There we go. So that's the demo. All right. So like if you are interested, like the spec and the OEM runtime implementation, they are all open source and it's community driven. It's open spec and open like it's Go project. So and the runtime is also a joint effort with Crossplane as well. So feel free to join our community calls and join our mailing list and ask any questions, and any feedback are welcome. Thank you.
All right. Well, we're happy to take any questions on either the demo or the talk. So the question is, do you have a bunch of standardized CRDs with operators on top of them? In terms of the implementation, maybe Hongchao, you can speak more to that. But I think that's probably what it boils down to, at least for the Kubernetes version of the implementation, right? So the specification is designed to be platform neutral, but for the implementation that we do have on Kubernetes, it does basically comes down to CRDs with operators. Hongchao, if you want to go into some more detail on that, on how the Kubernetes version is implemented.
Yeah, and for the Kubernetes version, like in the Kubernetes runtime, we also have a project called Catalog. It's actually implemented a bunch of operational traits as capabilities. But like on the user like view layer, we use OAM to structure and group those capabilities better. Yeah.
Looks like there was an issue with the sound. Hongchao, would you mind repeating? Would you mind repeating your answer? I'm not sure if people can hear you.
Okay, but you can hear me now. Yeah.
Okay. Yeah, it looks like they can hear us now. Go ahead, Hongchao.
Okay, sure. So you can hear me now, right?
I can hear you if that helps.
Okay, yeah, that sounds good. So the answer is like for the OEM like runtime, we also like implement a couple of like traits in the form of like operators and CRDs. So we don't reinvent like what the infrastructure does. We just reuse whatever is provided in the OEM platform. Yeah, but like it's like the OEM works at the user view like layer. We provide better way to structure and group those capabilities, those CRDs, in a more user friendly like form. Mm-hmm.
So here's a good follow-up question for you, Hongchao, and you might be able to answer this one as well. There's a question about where do you see this in comparison with Knative, and I'm looking to you to answer that one because I know you had worked on an implementation of Ohm on top of Knative, so maybe you can help clarify how this compares with Knative.
Like I think there are two points that we can compare them. Like first on the platform layer, like Ohm doesn't conflict with Knative. Ohm is designed to be an open like format that like you can include Knative as a part of the Ohm. Like for example, Knative serving can be modeled as Ohm's workload, and Knative serving and the Knative like routing and scaling, all those can be modeled as traits. We also have some implementation that's replaced the Knative scaling with Keda, which is another open source project, and for auto scaling as well. So like the Knative model is more, I would say like more limited, but Ohm's model is more open and extensible. But we also have a lot of users asking us like how do you see like Knative versus compared to Ohm? And that's from user view because like users are using both Knative and Ohm to deploy applications. I think they sort of conflict here. So and because like Knative also has its own CLI and UI and those tooling for developers, we also have some developer tooling as well. I would imagine that one day they will be converged together once we can provide Knative more natively on Ohm. Then you can use Ohm's developer tooling to deploy Knative applications. Cool.
All right. Any other questions? If not, I think we can probably call it for this one.
Mm-hmm.
All right. Well, I hope everyone enjoyed the presentation. The community links that we have up on the slide here will take you to the Ohm project as well as the implementation, the reference implementation that we have for Kubernetes built on Crossplane. So please do check those out. We hope to see you there. There's one more question: are there any plans to have non-Kubernetes runtimes, and if yes, which platforms? Yeah, so I mean it's kind of that's sort of the long-term plan, is to have additional runtimes outside of Kubernetes. We're targeting specifically cloud providers as well as other form factors that go beyond cloud environments and beyond containers as well. So the spec's kind of designed for this and allows it. I know we have some work in Alibaba Cloud that maybe Hongchao can talk about. That is an implementation of Ohm. There's also a project out of AWS in AWS Labs that supported Ohm. So there are a few of these, and there are more planned, or I should say, we do plan to see more runtimes in the future. And Hongchao, if there's anything on your end that you want to add to that, go for it.
I would just like talk about my experience. Like previously, we also have some like non-Kubernetes runtime, like for example, based on VM, based on like custom environment. But like now, as Alibaba is moving towards like cloud native, unified like environment. So we just like all of our implementation are based on the Kubernetes runtime now. So it's pretty unified. Okay.
All right. I think we can probably wrap it up with that. Great. Well, thanks so much, everybody.